So I'll talk about a few topics about space and space technology, specifically some of the missions that NASA is undergoing right now. And one of the reasons to cover this topic is that in the future, I will cover a lot of other topics on space technologies and both the technologies and the startups working on them. And if I talk about them directly, it won't make a lot of sense. At least it doesn't make a lot of sense to me because for me, the whole objective is to get a bigger picture and then zoom in. That gives me a better context and helps me understand things better because it helps me connect the smaller things to the bigger picture, how things are happening. And I think a few months ago I talked about the space economy. So since then, I think, updated my own understanding about how the space tech economy works, and maybe I'll talk a little bit about that right now. So broadly, the last time I talked about was mostly I could say that that's the Earth orbit economy because the whole system back there that I explained there was that there are the rockets that launches the payloads to Earth's orbit, which is mostly satellites and other related payloads. And those payloads collect data from space, Earth's data from space, and beam it back to Earth, which then are analyzed, and there are various applications to that. So that's broadly the Earth economy, like Earth orbit economy, that I would classify it as Earth orbit economy because that is limited to the Earth's orbit itself. One more thing that I did not cover there was that when I talked about bringing. Yeah. Yeah, okay. So one thing that I did not mention the last time was that in this Earth orbit economy, was when it's about bringing things back to Earth, it was mostly data. It had to beam data back to Earth. But there's one thing as well. What about bringing physical things back to Earth? So it is actually that area has a lot of scope actually because the technology is not more developed. So the saying there is that getting things off Earth has become much easier, but bringing things back to Earth is much more difficult. So unlike SpaceX, which has a very high advantage, and if not a monopoly, but it has a very big head start in terms of taking things from Earth to space. But it's still very competitive for bringing physical things from space back to Earth. And one of the main things that is required to be brought back to Earth is things that are manufactured in space, which is called in-space manufacturing. Now, I'm not going to go into details there because that is not a topic of the day currently. So I'm just briefly describing it, just adding it to the discussion. That there are companies and startups working on that too. That how can we safely bring physical things that are manufactured in space to be brought back to Earth? Now, there are a lot of things that could be manufactured in space because it has zero gravity and certain things are much easier, or in fact possible only in zero gravity, which is not possible in Earth, in gravity, like in Earth's surface. So those are the scope there. So broadly, that's about the Earth orbit economy. So in futures sessions, I might talk about a specific technology or a specific startup working on certain aspect. So now that we know that this is all part of the Earth's economy, like the Earth economy of space, so it will be much easier to put it into the broader context. The second is the moon economy. That is, I think this is my classification. I don't know if there's an official classification such like this or not, but this is my classification. That this is the moon economy because this is not about going to orbit and bring things back to Earth. It's about doing things on moon. And finally, the third category as of now is beyond moon. Maybe in the future when there is settlement in on Mars, then maybe this categorization can be more magnified, like Earth orbit, moon, Mars, and then beyond. But currently, I will include anything beyond moon, including Mars, is in category 3, which is beyond moon. The second part is moon. So where there are technologies and there are startups and even established companies working on technologies that are all part of the moon economy, the things that are going on in moon, the missions that are being carried on in the within moon. And the whole catalyst behind the moon economy is the Artemis mission, because that's the whole thing that has started this all off. And unlike the previous term when the US landed on moon, which was largely government based, this time it has also included a lot of commercial players. And today I'll just briefly go through things, but I will go through the specific companies in future sessions. One of the reasons is that why commercial players? Because so that it becomes a sustained thing. It's not their goal is not to make this just a one-time thing. Because the risk with NASA doing everything is that NASA gets its budget from the government, and government might change its allocation to this kind of programs based on what is happening in the economy, in geopolitically, and so on. So if there's a war going on, there's no point doing things on space. So we'll put our funds into war and or maybe any other thing instead of space. So it is dependent on the government and their scenario. But if there is if they are able to bring a commercial interest, then regardless of whether government wants it or not, if there is a commercial viability there, then things will keep happening. So it will become a sustained presence, and not just one-time presence. So that's the whole idea behind including commercial players. And from my point of view, the second idea is that it is about competency. One, again, there are a lot and lot of things that are need to be done in the moon. And I don't think it's practically possible for one agency or maybe or even one company to do these things. It will require different sets of teams, different leaderships, different scientists, different mindset, different workplaces to do different things. If just one central agency like commanding everyone to do things in this way, it won't happen. So that is another thing that is another reason I think commercial players are involved. One agency doing everything is not going to happen because it will need diversity of ideas and things. So in terms of moon, currently the plan, there are two major plans here from the US government. One is the Artemis mission, and the second is the moon-based mission or moon-based plan, which is not uh, as structured as the Artemis plan, but it is also a like a proper way of going about creating a permanent base on moon, which was actually announced on 24th of March 2026 by the new NASA administrator. So initially, the objective of Artemis was Artemis had a very specific structured goal to bring people to make land as astronauts on moon once again. The objective of the moon base is to actually build a base on moon, not just for one-time thing to build a permanent base. So that is a separate thing. Today I will not cover the moon base plan because it is a separate topic in itself. Today I'll cover mostly the Artemis plan, and within the Artemis plan itself, there are a lot of private players working on that. So broadly, the technical, like the non-technical way of explaining the whole process is this. So the Artemis contains mostly three phases, the Artemis program. So there is the Orion capsule, so which will actually contain the astronauts and their whole living habitat. That's the first thing. The second thing is the Space Launch System, SLS. That's the actual rocket that will, on top of which the Orion will be mounted on and it will be launched. And once it reaches a certain stage, the SLS will come off. The Orion will be the one that will move all the way to the moon. And once it reaches the moon, the third step is to reach the moon's surface. So there's another system which is called as the human landing system. Now this will be developed by either SpaceX or Blue Origin. So these are the three phases. So far, what's been done? So we had Artemis 1 and Artemis 2 completed. 3 and 4 are remaining. So Artemis 1, what's been done was that the space launch system was tested. It was an unmanned mission. There were no person within the Orion capsule. So the objective of this test was that whether the space launch system can successfully launch it or not, and the Orion can completely successfully revolve around the moon and come back or not. That was the test, which was done in 2022. Now on April 2026, the Artemis 2 program or the mission was done. The objective here was exactly the same, but one distinct differentiation is that instead of sending an empty Orion capsule, within that there were humans. So this time they tested the what is it called? Whether the capsule is able to sustain humans within the system or not. That's the objective. So in 2027, there will be Artemis 3. The objective here is initially the objective was to land in Artemis 3. But now what they do is that they will not test the docking system in Earth's orbit. So remember, I told you that the third phase is to dock the Orion capsule to the human landing system. Now from which they will descend into the moon. So this docking process is it's a complicated thing. It's not just very simple. I think there is a very famous scene in Interstellar, and the music has also become a kind of a meme currently, where the thing talks there. So that thing is there. So now what they'll do in this mission is that in Artemis 3 is that they won't try the moon's orbit. They will try this whole docking system with the human landing system. The whole docking process with the human landing system in Earth's orbit itself, along with humans in the Orion capsule. So that will be the part 3 of the mission, and part 4 will finally be to do it for real in on the moon's orbit and finally land on moon. But by the time they land on moon, there will already be a lot of equipments there, already being sent. In fact, it has already started. Some equipments are already there. It's not that they'll come with the whole package, everything. In fact, most likely the humans will be the last part of the whole mission. It's like, the humans have arrived now. But the whole equipment, the scientific equipment, and all the other equipments are already being shipped off in stages. And here's where the commercial players come into play because these are almost exclusively done by the commercial players. In fact, the only thing being done by NASA in terms of apart from the whole strategy and planning, the only practical thing done by NASA are the space launch system and the Orion capsule. Those are built by NASA engineers. Even as I've said, the landing system from the moon's orbit to the moon's surface will be done either by Blue Origin or NASA. And all of those equipments that will be sent, there's a specific program that they have named called as CLPS. It's called Commercial Lunar Payload Systems or something like that. So this is another specific program under which they assign contracts to commercial players, which are mostly smaller companies and startups, which have dedicated and specialized expertise in certain space related things. So they are the ones that are playing, that are doing all of the things. Now, I've already written a few articles on some of these companies, and I'll also speak about the technology and the things that are practically doing in future sessions. But now I had to give the big picture. Otherwise, if I just randomly pick a company and start uh, talking to you about, okay, this company is doing this, landing this, and like in your mind, the question will be like, yeah, so what? Like, what's the bigger context behind this? This is the bigger context behind this. So that's the whole plan. Like before the the humans reach on moon, the equipments will already be sent there by the commercial players. In here, the NASA will only tell them what to do, like what exactly the equipments to send, but all the details will be up to the commercial companies. So that was the overall picture of the whole, broadly the NASA Artemis plan. The moon base plan, I haven't covered it, but yeah.
So, could you like maybe briefly differentiate what is the Earth orbit economy and the moon economy you're talking about? What was the difference?
See, the way I have differentiated it is that what is the objective? Like for me, the the reason behind why I started to differentiate this was that to understand uh, the purpose behind the startups and companies that I was looking into. So whenever I look into some space news and space technologies, the first thing I said, okay, this company has developed this technology, or this startup there's a new startup raised this much funding for this technology. Then my question always comes to it is, okay, so what's the whole, like the bigger picture of this thing? Like, why are you creating this technology? Why are you creating this company? Because you can't be randomly doing things, and they're raising hundreds of millions. So people are not just randomly giving away hundreds of millions of dollars just for nothing. There has to be a bigger picture to it. So as I was piecing the things together, this is how I came into thing. This is how I started to get this structure. Like the companies were either building startups, like the startups were building their solutions. Mostly they fell into two categories. Well, either they are doing something related to the Earth's orbit economy, either doing launching satellites, some new technologies to do something more efficiently within the Earth's orbit, or they are doing something within the moon's economy. That's the thing that is how I've tried to differentiate those things. So that's how I've come up with the differentiation.
You also said that certain things are easier or only possible to manufacture in zero gravity. What kind of things are we talking about?
So one thing that what I heard is ball bearings. Like let me see what you see this kind of thing. This perfect
Yeah.
spherical metals. So because these are never as perfect as it looks, it is never very perfect when it is made within the Earth's surface. Because whenever you're manufacturing, the Earth's gravity pulls on it, and there's certain like deficiencies that eventually comes up, which does not happen when you're not doing if you're manufacturing this in space, there's no gravity to pull it back. So there's no deformities, no, not even any minute deformities there. So you can make a perfect ball bearing in space. And I think, and why do you need perfect ball bearing? I would say that I think it would reduce frequency or reduce inefficiencies, and those perfect ball bearings that these things might last way longer. So I think the benefits will outweigh the cost of manufacturing it in space. That is one thing.
So then, is there companies or is there plans for companies to manufacture not just ball bearing or like any other things in space as well? So is there a complete plan or
I
is
think
it just theory at this
there
point?
I think there are a lot of companies doing a lot of things. I haven't looked into it, but I'm quite sure there will be. And that is my whole objective over the coming weeks and months to one, now that I got the bigger picture, now I'll pick and choose a specific company or multiple specific companies, look at what exactly they are doing, and then write about them. I think I've actually covered quite a lot of them. Like there are specific things that they're doing within the Earth's orbit economy. So, okay, I do not have exactly the companies that are doing in space manufacturing, but another area of doing in space manufacturing is related to biotech. So there are a lot of things that cannot be done on Earth because again because of Earth's gravity. Let me just search. It's better. Yeah, we said biotech. This is the first example is that of a biotech. So it's a US-based startup that manufactures pharmaceuticals in LEO, low Earth orbit. I think I looked into this website once. They This is a very extensive data set of what different space manufacturing companies are doing. As I said, this is a 3D printing solutions. What are they doing here? First ever experiment on 3D printing of live organic tissue and organic constructs using bioprinters on board the ISS. Also, yes, so there are a lot of, so in theory, I could go into details, research and go into details about what each of these companies are doing, what exactly they're manufacturing in space. But there, as you can see, it's a very extensive. I think it looks like there are hundreds of companies doing something or the other related to in space manufacturing. And again, this is in space manufacturing is just one aspect of orbit economy. And so there are different areas of space that is happening there. So probably that's the whole point here. So I think the recent one that I wrote is about something called about this company, New Orbit. So again, so briefly, what this company is doing is trying to develop a satellite that orbits in very low Earth orbit. So very low, so practically, as the name suggests, it is beyond the low Earth orbit. So, so technically, it's the lowest, like the lowest, what is called the band, at the lowest level of the Earth or of the LEO. The LEO has a range. Like it is not just one point of view; it's a range. The lowest range of the LEO is called the VLEO. And why is it doing this? Because the LEO has become very crowded. There are hundreds of companies, and I think there are lots and lots of satellites there. So it has become very crowded. So now the point is to look at places where there is less traffic, and one of the ways to do it is to come lower. And apart from that, there are also benefits. The benefits are that, okay, so if the satellites are lower, then the imagery and the data collected about regarding the Earth's surface would be much more better because the pictures are being taken from a lower height compared to the Earth's surface. So there are those kind of advantages. The disadvantage is that As you come closer to Earth's surface, the Earth's atmosphere starts to get thicker, which creates resistance, which is very minimal in the low Earth orbit, but it grows considerably in the VLEO bandwidth. So they are developing new technologies to sustain, because it is not just reusable. You can use a satellite that's been designed for LEO to operate in VLEO. It will quickly disintegrate and fall back towards surface. So certain innovations are required. So here I go into the details of what exactly this business is doing, how they are developing new technologies and new systems to overcome these challenges of orbiting in VLEO. And I'm working on several other such technologies or companies and their technologies within the space economy as well. This is just one example.
So then is there any kind of space race this time? Any other companies or countries
Yes,
also eyeing something similar?
yes, in terms of space race, it's mostly the whole thing started because of China starting this thing. And there's like people, experts in the field think that it might be China who gets there faster than the US. So it might be a possibility. It's not guaranteed, but
So do
it
you
might
mean
be a
get that
possibility.
like it's just sending humans to moon?
Yes, sending humans to moon. That is the whole reason why, despite the PR and marketing saying that, okay, the next generation of pioneering human curiosity and so on, the whole reason this thing restarted again is because they want to again beat someone else to the moon again. This time it's China. And
What about the rest of the economy point of view, meaning the space economy point of view?
space economy point of view, there are other Europe has their own systems, and there are companies in Japan and even China as well. But the thing is that it's when it comes to commercial players, it's not a race, because the whole point is that they just want to make money. They have no intention of ruling or anything. So wherever they have have a chance of making money, they'll go there and make money. But yeah, I think again most of the startups, I think even in I think apart from China, even most of the European companies are mostly in-orbit companies, not related to moon, because uh, the Earth's orbit economy is becoming more economically viable to build startups on. The moon is still a very experimental stage. You can't like it's you have to be very forward thinking to build a company with the hope of making money in moon. So and also it won't there has to be a government initiative behind it. Otherwise, it won't. The whole thing about Artemis is that there are a lot of startups. If that won't, if suppose NASA were to close this mission right now, this the value of all those startups will go to zero. They'll go bankrupt. They'll have to close it down, because right now nothing is there in the moon's surface to worth like to justify the money being spent there. There has to be a push from the government side for the initial progress. That's the thing. And so I think I'll just go through this 5-minute video, which is essentially a summary of what I just said about the Artemis mission. And this is actually quite old, from 2019, when they actually, I think so, when they just gave a brief overview of the whole mission. So here you can get a brief overview of the whole mission.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
But this is the whole big picture plan about what they're trying to do. But they have had some modifications. They mentioned about this thing, this lunar gateway, this thing. Now this has been cancelled, not cancelled, it has been postponed currently, and it is being replaced by the so-called moon-based mission. So, and as it was meant, so when I did further research, as it is mentioned here, that this is from this animation, it looks like it is very necessary to in order to descend into the moon. But when I looked into it, it's not that necessary. The main objective of this thing was to have a uh, kind of like an international space station equivalent of this thing. That people will come there and maybe there will be a whole working environment within the moon's orbit as well. And it could also be used to in the future to go into Mars as well. But right now this has been suspended. So this won't be there as of now.
So this is acting like the moon base itself, like the similar to ISS.
Yes. So that's why now they are actually they have expanded. I think previously the whole point of having this base, which they actually named is the lunar gateway. I think through the concept of moon base, they have actually expanded this thing. Have instead of having a small thing to go like in the Earth's orbit, they're focusing on building a more sustainable base in the moon's surface itself.
So in the beginning, they were showing the spacecraft and the amount of fuel. So they said, what was the total weight? 8 million pounds or something, out of
Yes,
which 5 million pounds is the fuel itself.
yes,
And as per the animation, like the area storing most of the fuel is used up during takeoff itself. So is that really how it works? Like during takeoff itself, almost all of the fuel will be used up.
yes. That's what it happens in when launching rockets. Like most of the energy is like taken up while launching in the initial stages itself because
Just to
uh,
escape the Earth's
yeah,
gravity.
just yes, exactly, just to escape the Earth's gravity. So most of the weight of the spacecraft and plus the whole idea about the fuel itself goes into that. So yes, that's the thing. Now, one of the things that they'd also mentioned, like it is a very big.
Saturn V of the Apollo era in numerous ways. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways.
So it talks about this Saturn V back in the 1970s, 60s and 70s. So this is almost as big as that, as per this, like practically bigger than that, the SLS. But there was another rocket that was conceptualized, that was designed but never made reality, which is named as the Sea Dragon, which was much longer than this one and much thicker as well. But it was never practically built. But in the show For All Mankind, like as I've said, it is all about the moon race. So they had actually built the Sea Dragon in the show, and yeah, it was really big. The first time I saw it, I think it was only shown once, but it was really big. Let me show you the video if possible.
So the one they show in the show
And
is uh, what should I say? It's similar to the idea they had in reality,
yes, like yeah, they had actually the
like from
concept
dimensions
was
and everything.
yes, like they had actually made it according to the dimensions. Yes, this is one.
Security's really high. Look at that. There's a whole carrier task force out there.
It just doesn't seem very safe. What if it explodes in the atmosphere?
That's why we're launching it from the middle of nowhere, Karen.
Look, it's risky, Ed. This isn't just another payload. That thing's carrying plutonium.
Expansion of the Jamestown colony. Ignition sequence. Start. 5, 4, 3, 2, 1. Ignition.
Maybe having them side by side would have given a better picture because we're just seeing one space comfort. And what was the reason it had to take off from underwater? Is there any scientific reason for it?
Yeah, I'm not sure why it was done. Maybe because it generates so much heat. Maybe that is my hypothesis. Like that could be one of the reasons, but I don't know why they have actually done that. So this could be the difference. So again, the Space Launch System, the SLS, is also almost nearly the same as Saturn V. So this would have been the difference between this. Much bigger. I think what I found was that the reason why it was never made is that there was practically no need for this. Like it has a very high payload capacity, but back then they did not need a rocket to have to launch that high of a payload, so they never actually built it. But who knows? Like now that this might be a sustained space race, so something like this could be built right now. Now, since I've mentioned that there are different private companies doing certain things, let me go through some of their YouTube channels and see what they are up to. Intuitive Machines are one of them. Lunar Lander.
Intuitive Machines propose.
So the thing is that the companies are now, it's like a commercial thing. Like it's this is what like normally happens in companies. Like a company puts up a tender and now the other companies puts requests for proposals like, okay, we are ready to take up your job. For example, when building a bridge, like a government says that okay, we are going to build a bridge. Different contractors comes and okay, this is our proposal for building a bridge. This is how I'm going to plan. Multiple contractors will put their proposals, out of which the government will choose one of them based on whatever the criteria is. So this is how it's happening in space for now in the United States now. So this is how Intuitive Machines are submitting their proposal for the lunar terrain vehicle delivery.
Intuitive Machines' proposal for NASA's Lunar Terrain Vehicle Services is under review. A decision is expected later this year. The team behind that proposal is Moonracer, a global collaboration of spaceflight professionals with decades of experience supporting astronauts, operating in harsh environments, and delivering for NASA, other government customers, and commercial industry. Our approach is straightforward. Deliver what NASA needs to operate on the lunar surface. That includes the terrain vehicle, the lander that delivers it, the trailer that extends its utility, and the commercial data transmission network that keeps it connected. One offering, one mission-ready package. The complete offering is supported by Intuitive Machines' cargo-class lunar lander, Nova-D, which builds directly on the company's Nova-C lunar lander flown in 2024 and 2025. Both landers share the same mindset: make lunar delivery dependable and repeatable. Nova-D is sized for heavy surface infrastructure and compatible with launch vehicles already flying successfully today. Moonracer brings these elements together in a vertically integrated architecture. From launch through surface operations, every part of the system is designed to work together, reducing complexity and increasing confidence. The Plus trailer extends what the terrain vehicle can do, supporting science logistics, cargo transport, and hosted international payloads. Our team is actively building civil and commercial partnerships across the globe to maximize the value of lunar surface mobility. The intent of Moonracer is that between crewed missions, the system continues working. Here on Earth, Intuitive Machines has already demonstrated the lunar terrain vehicle's robotic mechanisms and autonomous driving capability. The vehicle is designed to conduct surface mapping, sample collection, and support commercial payloads without waiting for human input. The Intuitive Machines team believes Moonracer offers a complete surface mobility service delivering, operating, and maintaining rover services for up to 10 years. This is Moonracer. One team, one goal, for the progress of humanity. Intuitive Machines.
So they are like a kind of a space logistics company. So from what I know so far, their expertise lies in building this lunar lander, which is this whole device. So the car that you saw, that is also another one of their capabilities is to build those kind of, I don't know what they're called, lunar vehicles or some, maybe they're called lunar vehicles. That is one of them. But apart from them, the whole box, which is what contains everything, which will also contain things, the other science equipment that they've mentioned, which may not necessarily be made by them, but they will be more like a courier service. Like, okay, in our box you can send those kind of things as well. So that's their expertise. Then there's another one. Uh, this is the only video.
To nations alone. Firefly is building the Blue Ghost Riders. The path to the stars is no longer limited to nations alone. Firefly is building the road to the next frontier, one mission and one dream at a time. Tonight, we didn't just reach another mission milestone. Together, we created a moment in history.
Chief Engineer on Ops. Y'all select the landing. We're on the wheel.
So, like, what's the achievement here? Like, is it like for a private company landing on the moon or something?
Yes, I think they are the first private company to land on the moon before intuitive machines. Yeah, I think that could be that. Let me just confirm it anyways. Yes, it's the first successful commercial moon landing. But this is also similar to intuitive missions in the sense that they also specialize in building lunar landers. And again, unlike NASA, which is a very end, like it's an end-to-end. Everything is done by had to be done by NASA previously in the 1960s and 70s. Here, things are very compartmentalized. Everyone specializes in something else. So Firefly doesn't have their own rockets. They do not launch in their own rockets. I think it was launched by SpaceX's Falcon 9. The rocket, the lunar lander was a payload on top of the SpaceX Falcon 9. And just like the animation that we just saw, that things come off and the Orion was the only thing that kept going. So the same happened here. The Blue Ghost lunar lander was the only thing that went going. So this is one of the, again, I think that I think we can call it to be a competitor of intuitive machines in the sense that both of are working on lunar landers. I think finally, I think one more company I can show is Axiom Space. They're building the spacesuits. They're yeah. Yeah, this is long. Just everything will look just 1, 2, 3 minutes of this.
Only 12 people have ever walked on the moon, and they all did it within just 4 years of each other. Then, for the last 50 years, no one has gone back. But that is about to change. Soon, astronauts will return to the moon to prepare for people to live there long term and to get us ready to send the first humans to another planet. But to do all of that, they need to be able to survive outside in space and work for hours in one of the most dangerous conditions a human being will ever face. The problem is, our spacesuits for the moon haven't been updated in decades. But now, to make this next chapter in space possible, spacesuits are getting a major upgrade. These new suits will give astronauts the superpower to do more for longer. And I am one of the first civilians to put one on. In this video, we're taking you behind the scenes to show you how they're designing, building, and testing NASA's new spacesuits. I'm gonna put myself and this suit to the test to give you a sneak peek into what it looks like, what it feels like, and how it might change what humanity can do in space.
Ignition sequence start. Liftoff. We have a liftoff.
Altitude 1600. The Eagle has landed. It's one small step for man.
One giant step for huge if true.
Are you ready to go see a spacesuit?
I have never been more ready for anything in my whole life. Like, this is the episode that is most what 10-year-old Cleo would.
Basically, there are a dozen things that are gonna kill you. The controversy is what order they're gonna kill you in. Most sci-fi gets this wrong. You probably wouldn't immediately freeze or explode. If you snapped your fingers and you were in space right now, your first problem is gonna be there's no atmosphere, meaning no oxygen, but also meaning no pressure keeping you together like on Earth. So the pressure difference between inside and outside of your body would immediately cause all of the air to just rush on out of you. Imagine a balloon. But don't hold your breath, because then your lungs might. Then in about 15 seconds, your brain would stop getting the leftover oxygen in your blood, so you'd black out, which is probably good because your body would be swelling up, since the lower pressure would then start to lower the boiling point of the water inside of your blood and your tissues, turning it into vapor inside of you. Though you likely wouldn't explode because your skin is super stretchy. Your next problem is temperature. Because there's no atmosphere, there's no ambient temperature around you. But if you were in the sun, the light would make that side of your body heat up to potentially 150 degrees Celsius, while simultaneously the other side of your body would be slowly freezing down to negative 150 degrees. Oh, and if somehow you survived that, you'd be getting so blasted by radiation that it would probably poison you and give you cancer. And you might eventually get shred to bits by flying objects going faster than bullets. But if you got rescued before about 90 seconds, you might actually survive. After that, though. So, spacesuits are really important. The first step to putting on a spacesuit is to basically sign your life away and get a bunch of medical tests. This is spacecraft. But not all spacesuits are the same. There are a few big buckets you should know.
One is what's called launch and entry suits, and the other one is what I would call EVA suits, or extravehicular activity suits. And that's the suit that we're working on here. Launch and entry are those orange space shuttle suits. They're the white and black suits that SpaceX uses. They're essentially high altitude suits such that if your vehicle experiences a problem and loses its ability to control the atmosphere of the vehicle, those suits become an atmosphere for you and allow you to at least re-enter to get back to Earth safely.
Spacesuits began in this launch and entry bucket.
So when you go back and look at the Mercury program, really what they were dealing with is these high altitude suits that protected you in case your cabin lost pressure or something like that. It's kind of like being on an airplane. They tell you like, hey, with your mask will come down if we lose air pressure, and that's to give you oxygen. The difference with spaceflight is you're so high, not only do you need oxygen, you also need a suit to keep the pressure on your body, right?
But as humans did more in space, we needed suits that could do more too. The kind of extravehicular activity suit that NASA uses is called the
Extravehicular Mobility Unit, or the EMU. Those are ones where you're outside, extravehicular, right? You're on the surface of the moon or you're floating in low Earth orbit. And those suits are the ones that let you go out and explore into space.
Some EMUs allow astronauts to walk on the surface, like this, and some are just for zero gravity, spacewalks, like this. But until now, an EMU has been basically impossible to fix in space, which is a problem if we want to live there.
That suit was originally designed for these 14-day missions of flying up, coming down, being refurbished, flying up, coming down, being refurbished. This is different than that. We've designed this suit from the ground up, from the very beginning, to be maintained on orbit or on mission. It's much more sustainable in terms of helping spaceflight costs come down over time so that more people can access space.
The goal is to bring down the cost of getting the suits to space, and also the cost of the spacesuits themselves. The NASA suits from the 1970s were each reported to cost about $150 million in today's dollars. NASA gave Axiom $228 million for the development of the new model, but the plan is to reduce the cost per suit as they make more of them. The future of space travel needs suits that are cheaper to make and cheaper to use.
It sounds like this moment reflects a major transition in the way that we're thinking about humans in space at all.
Absolutely.
Wow, that is very expensive. I never thought it would be that expensive. So that's not very. I don't know. I was thinking like, okay, like if people maybe in like 50 or 100 years, if like moon vacations become normal, then people might need this kind of suits to even walk on the moon. But if each suit like costs 200 million, that is again, they have said like they are attempting to reduce the costs, but still it is.
But also, like, they're not producing as much, like, it will not be just like a mass-produced item.
Yes, that is also true. Like,
So that is also a price.
yes. but 228 million, that is the net worth of a lot of people's. Like if you 228 if we assume it to be 250, like four of them would contain will if you buy four of them, it will be worth $1 billion. Like if you are a billionaire, if you're a family person with a billionaire, husband, wife, and two children, you won't even as a billionaire, you won't have enough money to buy suits for your family. So that's how expensive it is, to put it into perspective. So yes, let's see. Just a little bit of this.
For you to just think about while you're sitting right there is on a real EVA day, an astronaut will be doing this right here for about 13 hours. So you're in there for the next 13 hours. It's a challenging job.
13 hours. I'm wearing a diaper and I can't scratch my face.
So, together, the bladder layer and the restraint layer contain the atmosphere that you need and define how you can move. The final insulation layer helps protect you from all of these. That's the black outer layer. One thing you might be wondering is, why is it black and not the iconic white? The answer is because this is just a prototype. On the moon, it'll be white like this. And you might have heard that Prada is helping with pieces of the final design. But the color isn't just stylistic. They have to use white because they want to reflect as much light as possible to keep cool. This outer layer also protects astronauts from certain kinds of dangerous radiation and against cuts and punctures from dust and debris. They're still testing exactly what fabric to use to do all of that, and before I got into the suit, I got to see that process.
So here we've got one of our cutting tables, and so one of the things people may not realize is that this spacesuit is this three-dimensional thing. But it starts out as a two-dimensional shape.
And how much of this is like handmade versus like done by a larger machine?
So it's mostly handmade. There are some things that we've automated through machines. The cutting process is now automated. But in some cases, you're turning these machines by hand very slowly because of the precision that we need in the stitching. A lot of inspection, a lot of quality control on it so that we know that whatever we're building is going to be safe.
I'm a little bit surprised that it's so handmade. That precision is human precision as opposed to computer precision.
That's right, yeah. And some of that comes from, we don't make millions of spacesuits. So you would bring in that automation when you talk about a high production environment. But for us, we're not making those kinds of volumes. And so it's not really necessary right now.
I got to talk to one of the people actually hand sewing these prototype suits.
Sewing a spacesuit is a very unique job, even within the world of sewing. It's highly technical, very precise. So this crew of people, they're the ones that are making sure the suit keeps on alive, basically.
As I was in the suit, I could feel the craftsmanship that they put into it. It's an incredible.
Since they're sewing it through hand, I don't know how did they hire this kind of people? Like, what was the job description? Because on the one hand, you have these technical people who might have like PhDs from top universities in this kind of things, but they don't necessarily know how to sew or stitch clothes. But then on the other hand, there are people who know
part
that.
of their mechanical or whatever their expertise is could be included. So it is something they think about.
In mechanical engineering, you are saying that they know how to sew.
If you are maybe going into the area of building suits, spacesuit,
Yes.
probably there must be some kind of prerequisite of some fundamentals that you should know. I'm not saying during the degree itself, they will teach them. But if you are going to be working, then you would know what are the history of thing, what are the fundamentals, how they're made.
Yes.
That would require you to have certain skills.
Yes. But
And probably like sewing regular clothes and expertise for this kind of things are probably different career paths. These are not like regular designers. I don't think so. They're building regular clothes.
Yes, I think, yeah. I mean, the people who are doing the sewing may not be like they may not have a background in science and technology, but they might be like I expect this to be a bigger team. So the people who are like conceptualizing the science aspects of the technology are different from the one who are doing the stitching. Like they definitely have to collaborate, but in this video they've also mentioned that their Prada is working with them, so it's a very luxury clothing company kind of
Design or
things.
something.
Yeah, so design. So that gave me the idea that most likely they might have hired like people from the what is it called, the fashion or like clothing industry to do certain things as well, like offer their insights. Like obviously they'll have to sit around, like the engineers and these clothing people have to sit around like brainstorm. The scientists will give their inputs and so on. So I think this was broadly a very big picture overview of the moon economy and the preview of some of the companies working in this whole moon economy. So now that I've covered a very big picture overview of this, so in the future when I cover some specific company, then I can be able to refer to the broader context, whether this company is operating in the moon economy or within the Earth orbit economy, and what exactly their product is doing within this whole ecosystem. So that was it about this whole thing. Do you have anything else to say? Do you have anything else to say, or?
No, that's all.
Okay, so since we're about to end, uh, let's just talk briefly about the World Cup here as well, so it stays for record. The predictions that I'm going to make. So you must have known about yesterday's game, Argentina versus Egypt. So Argentina, they were on the brink of being eliminated. So I think till the 79th or something minute, they were losing 2-0. And they weren't doing much, but in the last 10-15 minutes, they scored 3 goals and they went on. On the other hand, Portugal lost. Brazil also lost. So, like a lot of players, at least I think international careers have come to an end. Like when Germany got eliminated, Manuel Neuer retired. Then we have Neymar, who retired. I think Modric also retired from international football. And I think Ronaldo most likely will also retire. I don't think he'll go play anymore. I mean, international
Already
football.
announced, right? That he's not going to play international football.
Oh, Ronaldo.
Yeah. I don't know if
No.
it's a rumor or like some fake post or something.
No, he did not officially. There are some AI videos that's there, but he did not officially announce it. But most likely he will retire, because I think there's nothing more to know more for him at the international level. World Cup was the only thing that he wanted to win, and he couldn't this time. So then by the next World Cup he'll be 45. So if you couldn't do anything at 41, so at 45 he won't be able to do anything else either. So But the point is that the next World Cup will be held in Portugal. That's one of the things, alongside Spain and Morocco. So, but anyway, so let me try to make some prediction and see what will happen. What yes. But this is most likely the picture. Anyway, we have France versus Morocco, Belgium versus Spain, Norway versus England, and then we have Argentina versus Switzerland. So on the left hand side, my prediction is that France will go to the finals. So that's going to happen. But the one on the right, huh?
For quarterfinals, you're saying they will directly go to the finals itself.
And I'm not saying they'll directly go to the finals
No, I
from
mean, like,
quarter.
you expect them
Yeah.
to win the semi-final also.
Yes, I think from Belgium and Spain, Spain is going to win. Then the semifinals will be between France and Spain, where France will win, and then France will reach the finals. And from my point of view, they are going to win the finals as well. But still, before that, I'll come to the right hand side. We have Norway and England, of which I think this is the most difficult prediction for me because from the one hand, I want Norway to win, and I think they have the potential to win as well because Norway is in that category of team which, if you look at logically, they shouldn't be winning these matches because the quality of players that they have within them it's not up to the level of all the other remaining 8 teams. But they have
Even
very good.
Switzerland,
What did you say?
even compared to Switzerland.
Yes, I would say even compared to Switzerland, they are not because Switzerland are a team that do not have any like well-known popular names how like that people who do not watch football regularly would know. Even people who watch regularly, even I can't name a lot of the players that's there in their team. But they are one of the consistent teams. I think over the last 12 years or so, since the 2014 World Cup, they have always been in the knockout stages, and even in the Euros, they go further. So they are quite consistent. Norway, I think it's their second ever World Cup. I think the first since 1994, so first time in 28 years. So they're playing in.
Isn't there when his father was in the national team?
Yes,
Haaland's father. I mean,
Haaland's father was there the last time he was playing. So right now, Haaland and Odegaard are the only two like well-known players. Of course, there are others as well, but like top class players, I would put Haaland and Odegaard, and Haaland even one notch higher. So this is their strength. Like they have a very well organized team, not individual quality, but very well organized team. Plus they have Haaland, like who can score goals out of nowhere. Like it, so that's their strength. So they defeated Brazil. Like Brazil are the all-time like they won the most World Cups. They have some of the best players out there, and they beat Brazil. So that's the thing. And like Haaland scored goals like he was in a training session with them. Like he casually takes the ball and shoots them. So these are the kind of things that he is doing. So from that point of view, I think there's a chance that Norway might go there. And in terms of Argentina, again, I am not sure what's going to happen with Switzerland and Argentina. Like again, after what happened to Egypt, so it looks like Argentina might go there. So Yes, Argentina will go. So from my point of view, Argentina versus Norway is going to be the semi-final on the right hand side. From which again, I think again from my heart I want Norway to go, but I think logically Argentina is going to go to the finals. So it will be France versus Argentina.
It's like a repeat of last World Cup.
Yes, repeat of last year's final. But again, I'm more sure about the left hand side than the right hand side. Like left hand side, I can be sure like France is going to win this quarterfinal semi versus Morocco. Belgium is going to win against Spain. Then Spain and France. France is going to win and France is going to reach the final. That path is I'm very confident about that. On the right hand side, anything can happen. Uh, Argentina might also lose against Switzerland because it can't be sure. Because the past two matches, what happened was that even the match before Egypt, they played against Cape Verde, who were also playing their first knockout game. I think first knockout game, first ever knockout game, and they almost lost. They had to go to extra time and score a goal and win 3-2. Again, the same happened with Egypt. So they are able to get away because they are not playing with a very they're not playing against very organized teams. Now, if they come against organized teams like Switzerland, they might suffer. So like the right hand side is very chaotic. Any of the four teams has a good chance of getting there, but from my point of view, it would be most likely Argentina, if I have to think. Okay, let me rank again. Okay, first is Argentina, second would be Norway, third would be England, and fourth would be Switzerland out of these four, in terms of expectations from my side. So that's my prediction. Let me show you like Haaland's scores again. Because you'll see that he has taken it very casually. Nobody's trying to even attack. Everyone is just watching him. Nobody's trying to do anything.
Shoulder up.
So you can see like he has the opportunity to take an extra touch and place it like he's doing a like practice session. Like this is the one. He doesn't directly shoot it. He just pushes it with the ball with his leg once and then he takes the shot.
Bizarre intervention from Aya, who shoulder up.
This you can see the second touch. Like he has this much amount of time. Like normally what would happen is that once you get the ball here, you have very little time to think. Either you shoot or either you pass. Now here he took the ball. He decided that okay, I think it's not a good angle enough. It's not a good angle. So he takes an extra touch, like places it. Like this is the kind of things when like people just play like before they actually play when they're in their training like warming up. This is what they do. Like take a casual touch and they pass. This is what he's doing here. So and this is what he's good at. Like he will be invisible for most of the time, but out of nowhere he will come and score a goal. And there is another goal, I think in the round of 32, where the ball hit him. He was not there itself, but he scored the winner. Who did they play in the round of 32? I forgot. Who did they play? Yeah, Ivory Coast.
And that's it. Here goes again. He might provide more. He's still
Because
Tapped.
yes, even he was not very like confident because you can see his reaction like okay maybe the defender might get. You can see like he's even trying to go again there. So this so again he is like invisible for most of the time, but then he comes and does this kind of things. And some of the criticism like people face, like some people or even fans say, yeah, he's like doesn't have any skills, only just course tap-ins and those kind of things. But people don't realize that is also a skill, like to be on the right place at the right time. That is why he is able to score this much amount of goals. And he also has a YouTube channel where he talks about this thing again, like he himself calls himself like tap-in merchant. Like he makes fun of himself. Like in one of the prank, I don't remember which video it was. I think yes, this one.
Oh, my hands are. And I'm going to ask them all sorts of questions and try and like set them up. I'm going to ask them about like who's the best and worst hair in the league, who's the best striker, who's the worst striker, who would win in a fight between players, stuff like this, right? I'm going to try and bait them into saying like not you or picking other people. Let's do it. Let's get the first guy. Right, I get into position.
But you need to ask the questions like, what do you think of footballers on YouTube and that?
Alan's like his stuff's terrible. Why does he waste his time?
Do that. Yeah. Focus more on football and that.
Yeah. He's coming. Okay,
let's go.
I don't know. Where did he say he's a tap-in merchant? Was it earlier?
You're obviously a content creator.
Yeah.
Big Man City fan.
Yeah.
It's just something
That was a good time. Shut up. It's so sick.
You're a content creator.
Yeah.
Big Man City fan.
Yeah.
I don't remember, but yeah, in this video he said somewhere like normally people get frustrated when they're criticized, like, but he is the one, he himself mocks himself, like, yeah, people call me tap-in merchant, and he says, yeah, I think I'm a tap-in merchant, kind of this kind of things. And
What is that post saying,
which one?
The flu-like virus is spreading across the northern continent ahead of the world.
Yes. Yeah. I don't know what's happening there. But if it's real, then it might be what happened. Yes. Several players are falling really out of. Well, if that is true, then my prediction will have to be updated. England might win in that scenario, but let's see what happens. Yes, and one more thing that came to my mind while talking about this, while talking about his channel, like one comment I got was that Haaland's channel is what people are expecting Ronaldo's channel to be, because like you might remember when Ronaldo's channel was launched, like he instantly gained lots of followers. So I don't know, he has like 70, 80 million followers compared to Haaland. I don't think he has a lot of followers. How much does he have? 2.52. It's not much compared to Ronaldo's 70 or 80 million followers. But unlike Ronaldo's vlogs, not even vlogs, those are like very scripted interviews where Piers Morgan comes there and they all talk about him being the greatest player of all time. That's the only thing that gives happening. It gives more of a dictator kind of vibes. Like the supreme leader is there, everyone is from the media is praising him. Like that's the kind of vibe that comes from his channel. On the other hand, Haaland is more like a regular person vlogging, like going and talking to people and so on. So that's kind of the difference. So I think we can stop the recording here now.